I'd like to show you WebGIS using a platform called ArcGIS Online. This is a complete system of software and services that's already available to many of you. With ArcGIS Online, you can discover content and use it to ask and answer questions. It's a WebGIS, which is a new style of GIS, and it comes with extensive landscape content for the entire US. Esri's gathered together authoritative data, maps, and apps on topics that range from demographics and lifestyle, transportation and urban systems, to physical and biological resources like land cover, soils, terrain, and ecology. This landscape content is in digital form and ready to use. It's hosted by Esri, but derived from the authoritative source data, so it retains all that key meta information. This layer, for example, shows earthquake risk across the entire United States, derived from USGS. And there's many more layers like this available in this collection today. You can also share and work with your own data in ArcGIS Online. Here I'm searching for information on forests and pulling back a variety of data shared by other organizations, things like national forest boundaries, canopy cover, and forest declines. As you bring data into this WebGIS, you can dynamically integrate it in maps. This map is called Forests to Faucets, and it visualizes the importance of drinking water relative to forests. So yellow and green areas are less important, and the darker the blue, the more critical the watershed is for surface drinking water. And these maps aren't static. As WebGIS services, they're connected to the source information, so you can pull back more data in pop-ups. The key is being able to dynamically integrate different data sets. You can search against the platform for more information and bring data together. I'm searching for forest fire information, and the results might be features or imagery from any number of organizations. I'm going to add fire burn areas to the map. This shows fire burn severity from 1984 to 2011, and immediately we can see some areas of higher risk to priority watersheds. You can also complement your own maps with data hosted by Esri. These demographic, landscape, and ecological layers that we were looking at are available today for you to use in your own mashups. Let's take a look at this layer. This shows development risk across the US over the next 30 years. So the darker the red, the more likely the area is to be urbanized. And this is just one of many layers available for you to leverage with your own data sets. We've fused together 3 WebGIS layers, showing both development and fire risk to priority watersheds. This is the kind of information that can be used to inform forest management. So ArcGIS Online helps you discover and integrate content, and you can also transform these mashups into information products. We're going to turn this into an information product in 3 steps. First, save the map. Saving a map doesn't duplicate data, but points to the source so that the map is always up to date. Step 2, share the map. You can share maps with your colleagues, your organization, or out to the public. And step 3, distribute the map with a ready-to-use app. ArcGIS comes with a library of configurable apps that you can essentially drape over top of your map. This application is called the Legend app, and it presents a streamlined interface for exploring data and, of course, a legend to help interpret the information. On the other hand, this classic viewer app adds in a couple of additional tools, things like measuring distances and areas and changing the base map behind your fusion of WebGIS layers. With this approach, you're not only fusing content, you're dynamically pairing mashups with ready-to-use apps to turn them into an information product. And there's many more apps in this library, some of which allow you to combine multiple maps, media, and text to tell a story. Let's take a quick look at an example. This Map Journal app presents an overview of private forest ownership in the United States, describing the different patterns and priorities of family versus corporate and other types of ownership. Each chapter in the journal lets you pull together different content and visualizations to tell a story. For example, in this case, family ownership of forests by state, which as we can see is concentrated in the central and eastern parts of the US. These configurable apps make it easy to transform your knowledge into information products. So you've seen how the platform provides ready-to-use data and apps, but these WebGIS services can also be used in custom applications. This viewer allows you to explore different types of forest communities using a dendrogram. You can filter at multiple levels, between hardwoods and softwoods, take a look at different forest groups and subgroups, and you can also drill all the way down to individual forest types, like lodgepole or ponderosa pine. And these aren't custom map graphics. The app is dialing into real WebGIS services connected to authoritative data and filtering that data on the fly. There's endless possibilities for exposing your knowledge to different audiences. WebGIS technology also goes beyond exploring data into the realm of analysis and modeling. This is an app we call GeoPlanner, and it lets you perform landscape analysis and planning. As an example, we're going to look at forest management issues in this area outlined in gray, which is the Southern Rockies Landscape Conservation Cooperative. Forest management plans involve balancing diverse priorities, like economic development, hazards, and conservation. What we're looking at here is a draft plan that focuses on natural disturbances. So management options like community wildfire protection, managed fire, and insect and disease control. But how do we know that we're assigning the right areas to the right type of management? How do we know if an area should be managed for fire as opposed to something else? We make these kinds of decisions based on data. And GeoPlanner gives you tools to fuse WebGIS data to answer these kinds of questions. Let's ask a question about insect and disease control. Where are areas that could benefit from this type of management? This modeling pane has a set of WebGIS layers, both from the forest industry as well as the Esri landscape layers. It includes datasets like basal area density of different tree species, land ownership, and also impacts from different types of pests. We can choose from these layers and combine them to ask our question about pest control. Specifically, we're going to ask where we see impacts to lodgepole pine from the mountain pine beetle. For each of these datasets, you can weight data values based on your question. So we're emphasizing higher concentrations of pine, as well as areas that were hit harder by the beetle. You can also weight these different datasets against each other. So here we're starting with equal weights for all of these factors. As you run the model, the datasets are processed on the fly into a suitability map. So the more orange and red, the greater the impact to the forests. And the analysis is recalculated as you pan and zoom. You can also modify and refine the analysis. So we might want to emphasize higher concentrations of pine. We can rerun the model and immediately see how this impacts the results. Or we may want to change the weights on the variables. In this case, emphasizing Forest Service lands. This is dynamic analytical processing in a WebGIS. Next, we're going to use this information to optimize forest management. GeoPlanner gives you tools to create and modify your plans and designs. Now, we started with a management plan for natural disturbances, so options like managed fire and, of course, insect and disease control. We can use our pest impact analysis to refine this design. As we compare our plan with our analysis, we can see an area with significant tree losses, here in red. But our current plan is managing this area for fuels reduction. We're going to modify this design to designate this area for insect and disease control instead. As I make these changes, I'm using the analysis as a guide. I'm tracing the areas in orange and darkest red. High suitability in the model means that the area had high concentrations of pine as well as significant losses from pests. So I'm actually sketching against a fusion of different datasets at the same time. Now we've improved the plan to actually align with the issues affecting the forest here. We can also go further and evaluate this design against the analysis. This dashboard reflects the plan. The pie chart wedges show the amount of land assigned to different management types, Watch what happens when I click on Insect and Disease Control. GeoPlanner summarizes the analysis under those areas. The colors in the second chart reflect our pest impact analysis. Remember, the darker the red, the greater the impact. So with the amount of orange and red in this chart, we can begin to evaluate if we're managing for insect and disease control in the areas that need it the most. Apps like GeoPlanner illustrate the amazing kinds of analytics that you can perform using WebGIS. What you've seen today are all components of this WebGIS platform. These tools give you access to amazing content, help you fuse and understand that content, and turn that understanding into action. Overall, this ecosystem of geospatial technologies can revolutionize the way we make decisions for forestry.